All right, so I'm going to talk about 6.4, which is a pretty short lesson on just graphing logarithms. And so remember that when we talk about logs and we talk about exponentials, they are inverses of each other. So when we want to graph a logarithm, first of all, we really don't know how to do this with a graph. We can put numbers in for x and find y. That would be pretty difficult. So what we're going to do with this is we're going to rewrite that as an exponential. All right, so if you remember, you're going to take the base to this power equals this. Okay, so we did in our last lesson on 6.3. Now, in order to do this without a calculator, okay, which we kind of difficult with calculator actually, but let's go ahead and do an XY table. So in this case, I'm going to pick, let me turn the camera so it's not so crooked there for you. All right, so let's pick, instead of picking numbers for X, let's pick numbers for Y that we can put in. So for example, let's take this and let's put a 0 in for Y. Okay, so if we put a 0 in here, we have 2 to the 0. And so that equals 1, right? So we have x equals 1. We put a 1 in for y, then we have 2 to the 1, and x then would equal 2. How about we do a negative 1? So if we put a negative 1 in here, how do we make that positive? Well, we do that by moving it to the denominator, right? So this is the same thing. We just move the 2, it becomes a positive power when we move it to the denominator. So this would be 1/2. Maybe do one more. How about we just do 2? Should we just pick 2? Put a 2 in here. And so x is going to equal 4. All right, so let's go ahead and graph these points. So again, this is just a sketch. I don't have a great graph here, but so we have when y is 0, x is 1. Okay, so when we plot these points, I'll tell you just a second here. So 2, 1. So let's go over 2, 1, 1/2, negative 1, and then 4, 2. So here's our graph. Now, if I picked a number that was less than 1, it's always going to continue getting closer and closer and closer here to this y-axis, but it's never going to cross that axis, right? So we'll talk about that in just a minute. Now, what I want you, if you remember what we learned before, so if we graph the inverse and a function, then they should have a reflection over the line y equals x. So I just want to show you that. So let's go ahead and do the graph of, and see if this would be the inverse if we graphed y equals. And so what I really did here is I just switched the x and y. All right, that's what you do to find an inverse. And let's look at the graph and see if it is an inverse. So again, we'll do an XY table. So when we pick this, now we're going to pick for 0, and what is y? 1. Okay, if we picked a 1 for x, what is y? 2. If I put a negative 1 in for x, y is 1/2. And if I put a 2 in for x, y would be 4. So what I want you to look at, I really would not have had to do this XY table if this is the inverse, because notice what happens, just the x and y have switched, and that's it. And we know that, right? Because when we had a relation that had all these ordered pairs to find the inverse, as long as we want our values are different, we can just switch those x and y's. So we should have been able to look at that to see that it is 1-to-1 and that it will have an inverse because all these values are different, right? So we just flip these. So let's go ahead and graph this. So we have 0, 1, 1, 2, negative 1, 1/2, and 2, 4. And so in here then, right, this graph, and that's just the parent function actually for 2 to the x is a parent function for an exponential. But let's look at the line y equals x. If we do that linear line y equals x through there, do you see that that is reflected over that line? So that's just another visual of a function and its inverse. All right, now let's answer a couple questions about that. So looking now here, we're talking about this right here. I'll label these. Okay, so just looking at this one right here. Okay, what would be the domain? What would be the domain for this? So would you agree that on the x values, the domain, we're getting closer and closer and closer to 0. This is 0. So our domain is going to go from 0. And then where does this go? My x values continue to grow, right? So that's positive infinity. Okay, and then I'm going to run out of room here. The range. So the range is the y value. So we're only looking at this. We're just looking at this. So we're starting down here. So we start at negative infinity. This goes from negative infinity, and y values continue to go up, so that as this goes up, the y values continue to go up, so that is positive infinity. Okay, now, is there a vertical asymptote? Could you look at that and tell me where the vertical asymptote is? Okay, and again, we're just talking about this. So do you see this is getting closer and closer and closer to when x is 0, but it will never cross that? So that is your vertical asymptote, x equals 0. Okay. All right, now that's graphing that by hand analytically. Sometimes you'll be able to use a calculator on some of those, but I want to be sure that you know how to graph those by hand. Okay, so the next part on this 6.4 is just talking about how to translate a logarithm graph. And we've covered these quite a bit, and it's just kind of the same theme through all of this, all right? So here, within the parentheses here, remember we're going to have a translation, opposite direction. So this is going to be translation 4 to the left, all right? And it's horizontal translation 4 to the left. So I'm just going to do brief notes on this. I'm just going to say 4 to the left. But really, mathematical language would be better to say a horizontal shift 4 to the left. All right, so what's going to shift here? We're going to have a horizontal shift 6, right? And which direction is it going to go? It's going to go to the right. All right, what about this one? So first of all, what happens with this 3 right here? What's going to happen when you have a number, a coefficient outside of that? It's going to be a stretch, right? So that's going to be a stretch. So we have a stretch with a factor of 3. And then what kind of shift does this have? It doesn't have parentheses around it, so it goes the exact direction. So, and then it goes up 1, or a vertical translation up 1. All right, now here, this negative doesn't change this. If it's a fraction, it does. It's going to compress or stretch, right? But let's just look at this first. So 4 is, we're going to have the same thing we had here. We're going to have a stretch, the factor of 4. Okay, now what is this name? This is a reflection. This is going to be a reflection over the x-axis. I'm going to run out of room here. Over the x-axis. And then what happens here? We're going to shift down 8, right? So a vertical translation down 8. All right, I'm going to move this one over here just, well, maybe I can fit it in there. All right, so let's take a look at this one. This one isn't too much. So one more time, stretch of 4, reflection over the x-axis, down 8. All right, here, what do we have here? We don't have anything going on, no reflections in here. All we have is a shift down 8. So we have a vertical shift down 8. Now, in here, we have a negative within the parenthesis, right, in front of this, rather than here where it was outside, this is here. So that's going to give us a reflection over the y. Okay. And then this is just, it's not in parentheses, that's a vertical shift up 1. And then here, we have a negative on the outside, so let's begin with that. So that's a reflection over the x-axis. And then we come in here, and then we reflect it again over y-axis. All right. So that's just being able to kind of explain what's going to happen to that graph. So you're given just the general graph of this that we talked about. This is the same graph that we're talking about down here. We just take this original graph, right, which is this, and we're going to shift it. So if I do this, that means I would shift this, all of these points, 4 to the left. If I do this, I'm going to take all these points, I'm going to move them 6 to the right, which means that we're dealing with the x-axis, the x-coordinate of that point. All right, so stretch factor of 3, that means we're going to multiply. Stretch factor means it's going to get closer here, right? So we're going to multiply our y value by 3, and then it's going to go up 1. All of these points will go 1. Y value multiplied by 3, and then we shift up 1. So you can kind of get a feel for what that is talking about. All right, that is the whole lesson for 6.4. So I hope that works out for you and you have a great day. Thanks, guys.